Hello everyone, welcome to your first video lecture in physics. So today we're going to be talking about units. Units are something that you've probably been using your whole life. Maybe you didn't realize it. But we're going to be using them a lot in the course, so it's important to go over the basic units that we're going to see over and over again, and how we can rearrange units and even double check units to kind of make sure we've maybe solved an equation correctly. All right, so let's begin with this proposition. How tall are you? And if I told you I am 25 tall, you'd probably be like, whoa, what do you mean? 25 what? 25 inches? 25 feet? That doesn't sound right. Are you 25 centimeters? So this number I gave you, 25, it's really pretty much has no context at all because I didn't give you any units, right? So another classic example, how far away is Boston? If we write this symbol D with subscript B, distance to Boston, if we said it was 50, again, it'd be kind of a useless statement, right? 50 what? 50 millimeters? 50 kilometers? It turns out Boston is approximately 50 miles. And miles is actually kind of a weird unit that we're not actually going to use miles much because it makes much more sense for us to use meters in this class, and we'll talk about why in just a little bit. But yeah, miles we're not going to be using so much, but it is a unit of distance. All right, so instead of using miles, like I said, we're going to be using what we refer to as SI units. These standard units that we're going to be using are meters, which is a unit that measures length, kilograms, which is a unit that measures mass, seconds, obviously a unit that measures time, and sometimes we'll be using temperature, which the unit we're going to be using there is Kelvin, which is similar to but a little bit different from Celsius. All right, so we call these base units because we can use these units by themselves, right? We just have meters by itself, kilograms by itself, seconds by itself. But you can combine these base units in a number of ways to get different derived units. Right, so derived units would be combining one or two or more base units into another measure. So for instance, area, this would be lengths times length, right? Something, you measure the width of something, and then you measure the height, and then you multiply them together, right, to get the area of a square or a piece of paper or whatever you're measuring the area of. So this would be meters times meters, and then we would say area has units of meters squared. So speed would be another derived unit, and this is length over time, right? And so we'll often be giving things in things like meters per second. And, for your reference, 1 meter per second, think about walking, right? If you were to walk, your stride between 2 feet might be close to 1 meter. So if you're taking 1 stride a second, maybe you're moving about 1 meter per second. Density. Density is mass per volume. And so what would be the units of that? Well, we have our mass unit, which would be kilogram. And volume is length times length times length, right? So it would be kilogram divided by meters cubed. And there's other types of derived units as well that we'll be seeing. So one thing we'll be doing a lot of is having to, convert units from one unit to another. And so to talk about that, we're going to use this example, this question: how old are you in seconds? And often in physics, you might encounter a problem and think, how the heck am I supposed to know that? And off the top of your head, maybe you don't know it. But what you can do is start with what you do know and see if you can get from what you do know, from where, from what you know to what you want to know by just applying small steps, right? So how old are you in seconds? Well, I really don't know that, but I can start with what I do know is that I'm about 35.1 years old. And then can I use other pieces of knowledge that I have to get me one step closer to converting that years into seconds? So we can try that because I know that 1 year is equal to 365.25 days. And that might sound funny, right? Don't years have 365 days in them? Yeah, but what about leap years, right? Leap years happen every 4 years and they have one extra day. So on average, a year has 365.25 days. So if we were to think about that, take the amount of time, 365.25 days, if you were to divide that by 1 year, it would equal 1, right? Because those are the same. 365.25 days is the same as 1 year, so if you were to divide those 2 times, it would be equal to 1. All right. And so now we can think, okay, what about how many hours in a day, right? 24 hours in a day, so 24 hours over 1 day is also equal to 1. 1 hour is 60 minutes, and we have 60 seconds is equal to 1 minute. All right, so then we have our answer in years that I'm 35.1 years old. And what we can do is we can start converting those units. So we would multiply 35.1 years by 365.25 days. And if you were to just do this operation right here, right, you could convert your answer into days. So it'd be 35.1 times 365. And you would notice the units would cancel because we would have years divided by years, and those units would cancel, and we would be left with days. Okay, so now we have our answer in days, and we multiply it by hours, 24 hours in a day, and then days are going to cancel, and we're left with our age in hours. And then you multiply by this 60 minutes per hour, hours is going to cancel, and you're left with minutes. And you have how old are you in minutes, you multiply that by 60 seconds per minute, and minutes cancels, and you're going to be left with an answer that is in seconds. So it turns out when you do all the math that I'm about 1.107 times 10 to the 9 seconds. So for those of you keeping track from home, that is about 1.1 billion seconds. So I'm 1 billion seconds old. So you're probably, maybe 500 million seconds old. And don't worry, you'll get there. One day you'll be 1 billion too. All right, so unit conversion, again, this is something we're going to need to practice. And it's always important whenever we write down a number to always ask, did I write down the units, right? Because you might lose a little points if you don't write down your units on a number, and especially on your final answer on a problem. But I have a couple practice questions that I want you to choose one example and try and do the calculations and bring your calculations to class, with your writing out all of your conversions and showing us how the units cancel to give your final answer. And there's lots of different ways in which we can convert units in creative ways. So I kind of have 4 interesting questions here. And like I said, I want you to pick one and bring your answer to class. The first is, how many molecules of H2O are in 1 cup of water? And for those of you who took, chemistry in high school, you might be thinking already about, how many molecules are in a mole and how many grams per mole and things like that. So those are going to be calculations or conversions you'll want to keep in mind to figure out how many molecules of H2O are in 1 cup of water. Again, this is something you wouldn't be able to answer off the top of your head, but maybe with common knowledge pieces of information on how many grams are in a cup of water, for instance, and how many grams per mole, how many molecules in a mole. I don't want to do all the work for you, but those are some things you'll need to think about to answer that question. Next question here is, how many Jason Tatums stacked on top of each other would it take to reach the moon? So that could be a fun one to answer. And again, answer this question and write it on a piece of paper and kind of show your work. And then we'll discuss the answers in class. Next one is, how many bags of Doritos would it take for you to eat in order to gain 50 pounds? All right, so a bit of units conversions there. Last one is interesting. How fast would you have to go to reach the nearest star, other than our sun, Alpha Centauri, before you died of natural causes? So how fast would you need to go? And bonus question, I think this would be, well, I kind of want to do this one in class, but I'd be curious. Whoopsies. Go away. Sorry. I'd be curious to see what your answer is to this question here. How fast would you need to go to reach Alpha Centauri before you die? And then on that journey, what mass of oxygen would you need to bring in order for you to, keep breathing the whole time? So that could be a tough calculation, but I bet one of you can do it. I think it'd be really interesting. And again, this is to practice converting our units and to always kind of remember to write down units whenever we write down an equation. All right, see you in class.